So as a society does a risk analysis, they need data to guide them. So what we're going to look at next is the role of perceived risk versus actual risk. The perception that certain behaviors or activities or chemicals entail a high risk does not always reflect reality or the actual risk. So what do you perceive to be the highest risk of death in the United States? So please take a minute to answer that question for yourselves. Here's a second question for you. Is a person more likely to die from a bee sting, lightning, falling, or an earthquake? So take a minute again to decide: bee sting, lightning, falling, or an earthquake. Is the risk of death higher when you drive or when you fly? Well, here are the actual answers. The number one cause of death in the United States is heart disease. You have a 1 in 5 chance of that causing death. Cancer is second with 1 in 7, followed closely by stroke. So let's take a look here at the motor vehicle accident, 1 in 84, versus airplane, 1 in over 5,000. So very definitely more motor vehicle accident. Of course, that's because you spend so much more time in a car than you would in an airplane. And then to the other question, the second question, falling was actually higher than bee stings, lightning, and earthquakes. Okay, let's see. So overall, someone's perception of what is a risk may not actually reflect reality. The risk could be greater or the risk could be less. So people and governments and organizations tend to fall into two categories or two philosophies of risk assessment and management. The first one is innocent until proven guilty, and that is that a product or service poses an unacceptable risk only if it's proven so in practice or by research. And the second one is the precautionary principle. If a hazard is plausible but not yet proven, steps must be taken to reduce or remove the hazard. So a well-known example of taking the two different approaches is asbestos. Asbestos was known to be causing problems to workers, particularly workers that manufactured products that contained asbestos. And that was known in the mid-1960s. The United States did eventually ban asbestos in the 70s, and the European Union did not waited to ban it until 1999. And as a result, if the European Union had banned it in 1965, when the evidence first surfaced that it was dangerous, they would have saved two things. They would have saved $25 billion in cleanup, because when you have this already in ceiling tiles and floor tiles and so forth, very special precautions need to be taken to remove that before something can be, remodeled, etc. In addition to saving $25 billion, they would have saved more than 34,000 lives. So there are, so I'd like you to take a moment for yourselves to think, which approach or which philosophy do you typically have? Do you think you're more of an innocent until proven guilty when it comes to chemicals or biological risks? Or do you think you're more of a precautionary principle? So you might think about things like how you feel about vaping. That's something that's not been definitely proven one way or another to be a risk, but there is evidence, for example, that heavy metals can be brought into the lungs this way, etc. So you might act now with the precautionary principle, or you might go with the innocent until proven guilty principle. Some people might find that the coatings that they put on pans to make them non-stick is an unacceptable risk, and others might feel it is an acceptable risk because it hasn't been totally proven. So here's a concern. Many chemicals have never been tested. There's a debate about how many synthetic chemicals are out there. Synthetic, again, meaning man-made. And in general, the EPA says that there are 10,000 synthetic chemicals that have been introduced since 1950. Now, the chemical companies do disagree with that number. The basis for their dispute of that number is that the EPA separates as two distinct chemicals if there is as much as one molecule of difference between the two. And often that is what happens. You might have a very large molecule to which you add or delete certain other parts, and therefore the EPA considers it a separate chemical because we don't know whether that addition or that removal will have a different effect on the human body or the environment. Now, a lot of these chemicals were introduced in the last century, in the 1950s to 2000. And very few of them were tested because they were grandfathered. They were already on the market, so they were allowed to continue to be on the market. And roughly 2% have ever been tested to see if they're carcinogenic. The other concern with these synthetic chemicals is that there could be a synergistic harmful effect. Remember the example of tobacco smoke and asbestos. If a person has a health risk of 1 from smoking and 1 from asbestos, and they both are smokers and exposed to asbestos, then their synergistic risk is not 2. It's a greater number, such as 5, because these two chemicals are both acting together in the same target tissue and therefore cause more harmful effect. And the last concern is that a negative effect may take years to show up. So, for example, if someone starts smoking, they may not have any issues for many, many years, even decades. And so it's very difficult to sometimes know whether certain things are going to be harmful in the long term. So what can we do about that? So internationally, people have gotten together, governments have gotten together to identify and restrict certain chemicals that have been known to cause harm to human health and to the environment. So the first one was in 2001 in Stockholm. The Stockholm Convention was a gathering of 127 nations that were meeting to restrict the use of endocrine disruptors in particular. They identified 12 chemicals, the dirty dozen, that were to be banned, phased out, or reduced. And some of these chemicals include DDT, PCBs, and certain byproducts of manufacturing processes. In 2009, additional chemicals were added to the list. Okay, so finally, here's just a review of the key concepts. First, we face significant hazards from infectious diseases and from exposure to chemicals. It is difficult to evaluate the risks since many chemicals have not been tested, may interact synergistically, or may take years to show effects. Likewise, for human health risks from infectious diseases, there are emergent diseases for which we have not yet developed vaccines or even tests, and sometimes some diseases may act together to cause an illness. Third, being informed and making good lifestyle choices can reduce your risk from physical, chemical, and biological risk. Some other factors you should know of when you're studying this chapter are the major historical and emergent infectious diseases, the categories of biological diseases, including neurotoxins and their examples, carcinogens, teratogens, allergens, and endocrine disruptors. You should know about dose response, lethal dose 50 and effective dose 50. You should know about retrospective and prospective studies. You should know about the factors such as routes of exposure, solubility of a chemical in oil or water, persistence, and individual sensitivities. And you should know about the two philosophies regarding risk, the precautionary principle and the innocent until proven guilty principle.